So the second part of section 4.3 will be dividing rational expressions. So we're going to find the quotient, which just means the answer when you divide rational expressions. So in this example, we are going to multiply x plus 2 divided by x to the fourth minus 16. And also, we're going to multiply that times x cubed plus 4x squared minus 12x. I suspect looking at this that there's probably some factoring that will happen. So we're going to multiply here. And I noticed that x to the fourth plus 16 is a difference of two squares. So I'm going to write that as x squared plus 4 and x squared minus 4. And when I multiply times a number, like just to remind you, if I do 3/4 times 8, well, that means that I'm going to really multiply 3/4 times 8 over 1. And you can just multiply straight across, or you can look and see if anything in the numerator will cancel with anything in the denominator first. So I noticed that these things cancel before I even multiply. So the answer is 6. I can do that same thing when I'm dealing with polynomials. So this is going to be x cubed, that business. I'm going to factor an x out because every term has an x. That'd be x squared plus 4x minus 12 over 1. So I'm just turning that into a fraction by putting a 1 in the denominator. And if I think of my product sum for negative 12, I want things to multiply to be negative 12 and add to be 4, I can use 6 and negative 2 because that will work for that. So if I rewrite this, I have x plus 2 over x squared plus 4 doesn't cancel, but it doesn't factor, but x squared minus 4 does. That's a difference of two squares. And then I can write this, since I just have a 1 as my leading coefficient, I don't have to do all of the factoring. I can just jump right to this part. I don't have to do the box part of that method. So then I can look for things that will cancel in the numerator and the denominator. I notice that I have an x minus 2 here and an x minus 2 here. Those would divide to make 1. I also notice that I have an x plus 2 and an x plus 2. Those would divide to make 1. So my answer after I multiply would be 1 times x times 1 times x plus 6 in the numerator. And then in the denominator, I just have x squared plus 4 times 1 times 1. So this is the product of those two expressions. I should also be really careful to note that anything that I canceled, I just, canceled these things and made 1. But anything that I cancel needs to be excluded from the domain. I canceled it, but I still can't divide by a 0. So I can't have x plus 2 equal to 0. So I want to make sure that that's outside of my domain. So I'll solve that. I get x can't be equal to negative 2. And then I have to do the same thing for the x minus 2 equals 0 by adding 2 to both sides. So x equals 2. That is not allowed either. I also thought about x squared plus 4, and I want to make sure that that's not 0. It didn't cancel, but it was in the denominator. But I know that that's not 0 because x squared is only negative if there are i's involved, and we're not going to use the i's for this. So this is called a domain restriction. The domain is all real numbers except for x equals 2 and x equals negative 2. Here's one for you to try. I'm going to make sure you pause the video and give it a shot. Make sure that you also think about anything that you want to exclude from the domain because it would be dividing by 0. So this was my solution. First thing I did was I factored a GCF out of the numerator. Both terms have dx in them. And then I turned that x squared plus 9x plus 14 into a fraction by putting a 1 in the denominator. I also noticed that I had a difference of 2 squares with x squared minus 49. That's the same thing as x plus 7, x minus 7. I was able to factor x squared plus 9x plus 14 by thinking about the product is 14 and the sum is 9, so I used 2 and 7. And then I was able to cancel on x plus 7 because x plus 7 divided by x plus 7 is 1. And then I also made sure that when I set up my, so I had 3x times x plus 2 times x plus 2. I rewrote that as 3x times x plus 2 squared because I just noticed that there were two identical factors. When I set up my domain restriction, I made sure I thought about the one that I had canceled, the x plus 7. That can't be 0. And also the one that's still there, x minus 7, can't be 0 either. So that's how I set up my domain restriction. We only look at the domain for the denominator for that domain restriction because we are allowed to divide 0 by numbers, but we're not allowed to divide by 0. All right, so if you're going to divide rational expressions, what we just did is really good practice for it. So the first thing you do is you copy, so I'm trying to find a quotient, so I'm going to copy my first term down, and then I'm going to multiply, and then I'm going to multiply by the reciprocal of the second term. So some middle school teachers say copy dot flop. The copy is writing down the first term as is, the dot is multiplying, and then the flop is using the reciprocal of the divisor. So what we're dividing by, we use the reciprocal. I'm going to look for any factoring I can do. It looks like I can factor out an x here. And in the other fraction, it looks like I can factor out a 3x. So we'd have x minus 6 when we do that. And then I really want to cancel these x minus 6's because they're almost exactly the same. But they're not exactly the same because their signs are different. So what I can do is I can take a negative 1 out of one of them. So I can rewrite this as 1 over x times x plus 9. Sorry, my dog is wanting to go outside. And when I take a negative 1 out, this becomes a negative 6, and this becomes a plus x. And those are now exactly the same. They're written in a different order, but they're the same terms. So this and this does divide to make 1. They have the same signs. And then I can also divide an x divided by an x. Those divide to make 1 as well. So my final answer is going to be 3 in the numerator and negative 1 times 9x plus 9 in the denominator. Be very careful that you're not deciding that you're going to cancel this 3 and this 9. It's not allowed. We're canceling factors, not just terms. I should also think about the domain restriction. I know that x can't be negative 9 because then I would be dividing by 0, but x also can't be 6 because of this x, this 6 minus x that I canceled. All right, here's one for you to try. I'll pause so you can try, and I'll let my dog outside. You started with copy dot flop, and then factoring to get the 2x as a GCF in the numerator here. And then you were able to cancel the x minus 6, and you were able to cancel the x plus 5. Even though they're canceled, they still need to be part of your domain restriction because both of them are in the denominator. So you have to make sure you think about them as part of your domain. This last example is an application. So we are trying to decide which packaging is better in terms of surface area to volume. So we're going to start with the rectangular prism. We're going to find the surface area divided by the volume. So that's why we're using our division because we're going to make that ratio. The surface area of a prism is going to be the area of all 6 faces. Since all 6 of the faces have the same dimensions, that would be 2x times 2x, the surface area is going to be 6 times 2x squared. So 2x squared would be the area of one face, but there are 6 of them when we're looking at a cube. And then the volume is going to be the length times the width times the height. And so if I look at things that would cancel when I do that, I have 6 times 2x, and that's going to cancel with the 2x's in the denominator. So I wind up with this cancels and this cancels and this cancels and this cancels. And actually 6 is the same thing as 3 times 2 divided by 2 times x. So actually the 2's cancel, and so we have 3 over x is the relationship between the surface area and volume in this situation. If I do the same thing with a cylinder, I'm going to do surface area to volume for a cylinder. The surface area of the cylinder is the 2 circular bases. So surface area for a cylinder is going to be 2 circles, and then one rectangle. If I imagine unrolling that cylinder, it would be a rectangle, and the dimension of the rectangle would be the circumference, so 2 pi r, times the height, which for us is 2x. So this one says that the diameter is equal to the side length. So if the diameter is 2x, that means that the radius is just going to be half of that. So if I do my surface area would be 2 pi times x squared plus 2 pi times x times 2x. And then my volume for a cylinder is going to be 2 pi times the radius times the height. So when I fill that information in, the radius for us is x and the height is 2x. So our volume is going to be 2 pi times x times 2x. Oh, 2 pi r squared, sorry. I forgot my squared here. So then if I simplify a little bit, I notice that I can factor a 2 pi and an x squared out of the numerator. So I get 1 plus 2. Well, that's just going to be 3. And in the denominator, I have 2 pi times x squared times 2x. So I notice that these cancel, and I notice that these cancel, and so I wind up with 3 over 2x. And it turns out that here that the ratio is 3 times what it was when I did the cube. That one was just 3 over x. Oh, it's half as big. So that is example 6. Good luck with division.